So Giovanna, how are you? And you're in Leiden, and that's a city in the Netherlands near
Right.
the Research and Technology Centre in Noordwijk. That's correct, isn't it?
That's
So
correct. Yes. Yes.
what's the weather like in Leiden?
Well, it's wonderful today. So unusual. It's yeah. No, we are having a good streak.
Good. Good.
And
So
I'm happy to be with you, although
lovely, yeah.
only virtually, but
Well,
very nice
we're
opportunity.
yeah, we'd love to hear from you. So please, in your own time, take it away. I think you should have sharing privileges, and we're really looking forward to hearing about your career and how you got to.
Yes. So as you said, I'm an instrument scientist. So I'm trained as an astrophysicist, and I work as an instrument scientist for ESA. And the so what is an instrument scientist? An instrument scientist is it's a scientist that look after the development and the calibration of an instrument for other scientists to use. And the instrument that I take care of is an NIRSpec. So I'm going to share my PowerPoint here. Yeah. So I have to put the play from start. So can you see the slide where you can see NIRSpec?
Yes, I can see it.
Yes, so this is the near-infrared spectrograph built by Europe, and it's one of the scientific instruments on board of the Webb telescope. Like you said, NIR is a spectrograph, so we use it to decompose the light and look for signature of elements in the spectra of lights. And from that we can understand what are the physical condition of the object that we are looking at in terms of air composition, temperature, pressure, density, and so on. So it's very important if you want to understand the physics that's going on in that particular galaxy or in the atmosphere of the planet, and so on. So this is the role of NIRSpec. This is mounted here at the back of the Webb Space Telescope. I don't know whether you can see my pointer.
Yes, we can.
Yes. So like the other instruments here, receives the light from the primary, is reflected on the secondary, and then focused here over the scientific instruments. And so NIRSpec will play a very important role in addressing the scientific questions that are the goals of the Webb telescope, and they are summarized in these 4-part slides. So from investigating what we call the first light, so the birth of galaxies, at the few 100 million years after the Big Bang, what we consider the beginning of our universe in our current model, and then study the evolution of the galaxies from this initial shapeless spheroidal form that we see, how they grow into the beautiful grand spiral structure that we see in our universe. In fact, we live in one of them, the Milky Way. And then zooming into our galaxy, study the birth of stars. And like you said, with the infrared light, we can really peer to the dust envelope that surround the young stars, and understand better the mechanism that are playing in the very first stage of a star life. And finally, study the exoplanets, so what we call the planets orbiting other stars, as well as planets in our solar system. But in particular with NIRSpec, we will be looking at characterizing the atmosphere of the exoplanets. So indeed looking at the composition of these other worlds, of these alien worlds, whether they have oxygen, water. Obviously, these are very exciting questions, as you can imagine. So I don't do the work as a project scientist, as an instrument scientist alone. I'm part of a large team. This is the JWST, is a science operation team. So I wanted to share with you these slides just to show again and to emphasize, like John did, how important is teamwork. These instruments, these experiments are extremely complex. So you need very different set of skills to do a proper job, and you can see the and we have that in our team with members from all over Europe. And one of the role of our team was when the web was on the ground, was being prepared. We looked after the ground testing of the instruments. Here you see a picture of the Webb telescope, so the primary mirror, the instruments are at the back, like I said, and it's going to be placed in this huge cryogenic chamber. So this is a chamber where you create a vacuum and where you reproduce the temperature that the instrument will be operating in space. So we're talking minus 230 degrees Celsius, extremely cold. And then we were in charge of taking the data from our instruments and understanding that things work as they should. So we are not the people in this white overalls. So these are mainly engineers and technicians. We sat behind terminals. And I want to point out these funny pictures. So this was indeed during this testing at Johnson, so where you saw the big chamber, and we were hit by a huge hurricane Harvey, and we had 10 days of pouring rain. And as you can see, we had to shelter our equipment under a plastic sheet. So not a very high technology moment, but we managed. And this is another cryogenic chamber at Goddard. This is from a test we made earlier on of our instruments. So that's where only the instrument alone, again, placed in this chamber that reproduced the condition of space so that we could analyze the data and make sure that everything was performing as expected. As I said, we work as a team, so we have meetings in which we discuss plans and issues that need attention. One of our role is to train the astronomical community in Europe. So here you can see people working with their laptops. So this was doing an event in which we presented our instrument and the tool that the scientists need to be able to use in order to perform the science with this complex instrument. And it was a 3 days training. And then finally on the right, this is a much more recent picture. This is a colleague, and he's finally looking at data coming from space. So NIRSPEC is up there and transmitting telemetry. And so we are looking at the data, and we are starting to performing the activity that will make NIRSPEC ready for the science. And that's the goal by the beginning of this summer, to have the first science observations. So to point the Webb telescope to look at stars, planets, globular cluster, galaxies, and see this under the new light and with the powerful instrumentation of the Webb. So that will be a very exciting moment, and it's a moment that we are really looking for, but we are working hard to achieve. There is a lot of things that need to happen from now to June before the instruments are ready for these observations. So I also try to capture here, just to counterbalance what looks like also quite a bit of a glamorous side of our job, which is certainly there, and it's certainly very interesting, but there is also a lot of everyday work with many hours at the computers. So one of the things that takes a lot of our time is email. We write a lot of email, we read email. Communication between scientists and engineers it's really crucial. We code. We write software. These data and these instruments are nothing like existed before, so we have to write our own solution and our own processing. And then we write technical notes to document what we do, what our proposals are, and occasionally we also write a scientific paper, either on our on instrumental aspects or also on science. Some of us are involved in the study of the physics of primordial galaxies or the atmosphere of exoplanets. So if I had to summarize in a few bullet points the work of an instrument scientist at applied physics, I think I'm going to just repeat very much what John says. There is a lot of data analysis, and this involves coding and using mathematical methods. As more applied physicists as we are, we have to think about the tests that we have to do with our instruments, the activities that are coming. So there is planning, solving problems. There are always issues, things that we don't expect, things that are more complicated to achieve that we had planned. Yeah, that's very much the fundamental activity skill. And then we have to document our findings, solution, communicate with other scientists and engineers. Occasionally we attend conferences where we present our results, and occasionally also we have outreaching activity in which we try to communicate our work and the excitement of the science that can be done with our instruments to the general public. So how did I get to do my work at the European Space Agency? So I come from a small town in the north of Italy. I gained a diploma from the high school, a state high school. None of my family had been to university before, so it wasn't an easy solution for me after my diploma. I was in a way interested in many things. I was interested in literature, philosophy, math, chemistry. was kind of difficult, but at the end I focused between. I was undecided between philosophy and physics, because fundamentally I was very interested in nature, understanding how nature works. I also come from an area with the dark sky, and I was also very fascinated by the night sky. And I thought that the approach of physics to understand our world is more practical. It's more like looking at nature and learning from nature, as opposed to the philosophical approach that is more maybe reading what other people think, processing that, and it is more intellectual, abstract work. Both interested, but for me at that moment, it felt that physics was something more close to my interest. So I did a bachelor laurea in physics, and I did like what the studies involved. I didn't mind there is a lot of math, but I didn't mind it. I took it very much as a game. Math, at the end it's a bit of it's a challenge, and you have to solve problem. Again, it's less studying and more challenge and more working out the solution in your own head. And then I like that. So I took a master in radio astronomy at the University of Manchester. You can see here the beautiful picture of the radio telescope near in Jodrell Bank near Manchester, and then a PhD of astronomy at the University of Milano. And then for personal reasons, I went to work for a software company for 1.5 years in England. But as I said, you learn a lot of coding as a student, a PhD student in this field. So it's not difficult to find this type of job. And I think this is very true also nowadays, especially with the explosion of data science. But at the end, I decided that was not really my world, and I really was more fascinated by fundamental question of the universe. So I applied for research fellowship at ESA, where I stayed for 2 years, and then I remain at ESA at the ESTEC Center that you see here on the right in the Netherlands. And I've been there since 2001. Again, when you look at this number, gosh. So a long time has passed, but as I said, it's been a very interesting walk of life. And I just want to finish with this slightly very light philosophical, as you say. I'm interested in philosophy, and stress that as well as the destinations, just as important thing is the path that we go through life. And so there are many paths to space science, there's the obvious STEM path, which I took, and I'm very, very happy. But as John said, there are also commercial aspects, law aspects, communication aspects in space science. So I think it's important to enjoy the path, look out for new vista, look out for opportunity, like Stephanie pointed out, many opportunity to approach things, try things out. So that's
great, Giovanna. Thank you so much. So interesting. It's so interesting, and we're getting lots of questions, people coming in. And again, don't forget, there is a prize for best question. We'll be shortly leaving our YouTube community, and the groups here joining us on the Zoom call will go into breakout rooms, and you'll be able to find out more directly from Giovanna and John. Such a fascinating career, and I think it's so exciting to know what James Webb is going to give us as well. It's just
it's going to be
we're all looking forward to it.